may or may not remember how to do some of this stuff. For number 1, you have to simplify these two polynomials. You were subtracting them. The easiest way to do this is to distribute the negative. Everything in a second. And then combine like terms. You can only combine like terms that have the same variable and exponent. So when you combine these like terms, you would end up with 4a to the third plus 6a minus 7. Questions on that one? Number 2 is asking, is this graph a function? It passes the root of test, so yes. Number 3 is something we haven't done in a while. I'm going to go back through this. Put these values in our calculator. If you didn't do this before, it's okay if you don't do it now. But if you want to follow along, you have to grab your calculator and go into that and put these in x1, or sorry, L1, L2, that would be your x and y, so 2, 4, 6, 8, 10, and 14, 13, and then 7. Then go back into stat, scroll over to calculate, find your linear regression, and that would give you your slope and y-intercept. To find your line of best fit, it would need to be put in this format. Your A is like your M, your slope, your B is still your y-intercept. And that's how you get y equals negative 0.85x plus 15.9. Questions on that one? For number 4 on the back, you need to combine your terms to distribute everything, and then combine all your x's together, all your constants together. Your final answer would be 25x plus 10. And for number 5, you have to graph this line starting at -1, and you have a slope of 4/3. So go up 4, right 3, as many times as possible, and down 4, the left 3, as many times as possible, and then see the terms. Before we get into our lesson for today, I did want to mention a couple things in regards to what Dr. said. My expectation is always, I'm not stopping you from using your cell phone, as you are all young adults. You are choosing to not pay attention. If you are choosing to be on your cell phone, it is always my expectation. Take that as you want. And then other related things. I moved your quiz date from Friday to Thursday. Also, I won't use it today, so I'd rather do it while I'm here. And so everyone should have this in front of them. This is the last set of notes for Unit 8. On the back of this sheet is review for not everything, but I want to say objectives 2, not 2, 3, 4, and 5. I'm sorry. Yeah. It's review of some of the things we've done already. So we'll finish this and practice some more tomorrow, and then Wednesday you'll get a review, another review besides the one on the back of this, so that you can practice the other two objectives. But today we're going to be talking about how to graph absolute values and quadratics. So we kind of already touched on the quadratic piece, which last unit, but we're going to revisit that, how we can do this kind of without a calculator. You will still have a calculator, still you can use it, but I'm going to show you how to do that without one. What's nice about both of these functions is that you can find the vertex, that point, the lowest or highest point. And I know it's been a minute since we did transformations, so we have to think back to what all of these things mean. But on vertex, we're going to look at this point, whatever this number is, but it's going to be the opposite. So if it says plus, it's really minus. Good morning and welcome back. I think they switched you guys with classes because you're whatever this is, it'll be opposite. So if it says minus, it'll really be plus and vice versa. And then we're also going to take the number on the outside, but whatever that is will be whatever it is. If it says plus, it's plus. If it says minus, it's minus. So our vertex, or number one, the point. It says minus one, which means moving to the right one, so it's going to be positive. This says plus 2, which means we're moving up 2, so that would be positive. So we can use that as our starting point and plot that point 1, 2. And then we have to remember what this function looks like. This is the absolute value, so that's your v. And there's nothing on the outside of this that's not going to stretch or compress or anything like that. So that means the original function, v, has a slope of 1 on both sides. So you go up 1, to the right 1, like 5 times. And draw arrows through all of them. So using your transformations, our parent function started at 0, 0, and it moved to the right 1, up 2, and nothing else. Now, we could put that back in our calculator, go to our table, and match the points, and that would also work. So I will do that for the test. In your calculator, remember your absolute value is alpha, and ADS is how to get there. So you could do one of two things: go into your graph, match the points, or go into your table. Negative 36, then negative 25, negative 1403. Match. And then 1, 2, and then it goes back. So you could match it using your calculator. Honestly, after you find the vertex, I won't know whether you used the calculator or did it by hand. The goal is to try not to rely on the calculator, but you will still have it if you need it. do we have any questions on that first one before we do another? Let's see what you remember. For number 2, what would your vertex be? Let's start there. We're doing the same thing we did with number 1. Taking the inside, making the opposite, and taking whatever the number is on the outside. What would the vertex of this be? So for this one, we're looking for the number at the end. Is there a number at the end?
What?
So 0. So we start there at -3, 0. Now, this one has that 2 in front. And you remember what that 2 does? Not lighter. If it was a fraction, it would make it skinnier. Yes. And with this, we have to remember our function of a quadratic, since it has that 2. I'm going to, off to the side, write a short little table. This would be the parent functions table. For the parent function, we had the x values -2, -1, 0, 1, 2. For our y values, that was 4, 1, 0, 1, 4. Since we have something that is being multiplied by 2, and this is the outside thing, outside things are vertical that affect the y's, we're going to multiply all of our y's by 2. So that would mean our x values would not change, but our y values would. We'll plot those points, and we're now looking at these instead. So, I forgot, but we also moved it left 3. So what would have been, since 0 was the vertex, but we have 1, 3. If we move 2 to the left, we would just go up 8. Here we go off the graph. And then 1 to the left of the vertex, we would go up 2. And then 0. 1 to the right of the vertex, we would go back up to 2. And then 2 to the right of the vertex, we would go back up to 8. So our table did change our x values because we also moved left 3. I just didn't show that part in the table. Or, so you could do it that way, or you could do it by remembering the pattern. Your original, from your vertex to the first point, there's distance of 1, and then between the first and the second, there's distance of 3. So it goes 1, and then 3, and then I don't know the rest. But if we're multiplying it by 2, that distance would also change. Instead of there being a distance of 1, there'd be a distance of 2. Instead of being a distance of 3, it'd be a distance of 6. You could also check that one in your calculator to make sure everything is right. -5, 8, moving 2 to the left from our vertex. -4, 2, moving 1 to the left of our vertex. Our vertex. -2, moving 1 to the right. And then -1, moving 2 to the right. The stretches and compressions for quadratics will probably give you the most difficulty with those. Without doing it with a calculator? So far, what questions do we have on that one? Okay, that's fine. Yes. Yes. Number 3. What would our vertex of this one be? No. There's nothing on the inside. -4 we see would be the second number. 0, -4. So this -4 moved it down 4. The negative on the outside, what does that do? I don't know who said that, but say it one more time. JR said. Yeah. So the slope hasn't changed. It will still be 1. It will just be facing downwards now. Down 1 to the right 1. As many times as the graph will allow. Because we know those transformations, we can find our vertex. We can use that. The vertex kind of tells us our horizontal and vertical shifts at the same time. And then we just have to figure out if there's stretches, compressions, if it's good flip. Number 4, what would the vertex of this be? Not -1. This one doesn't have parentheses, there's nothing on the inside. And the only thing that happened to this one is that it moved up 1. So that means our y values from our original will not change. It'll still be 1 or so left 1, right 1. And then from the vertex, go out 2 and up 4. So if you know those parent function, the original where they should be, moving it from the vertex should be easy. Questions on that one? Vertex for number 5. Not 1/2. The number in front doesn't really matter for the vertex. 0. Now that we're trying to graph it, that 1/2 matters. This is absolute value, so our slope is just going to be 1/2. So up 1 to the right 2, as many times as possible. And then up 1 to the left 2, as many times as possible. But match the points you have. As long as you have at least 5 points, you're good. Again, you could check this in your calculator and it should match up. Questions on that last one? We'll do 6 and then we'll be done for tonight. The negative is going to make it do what? What? Upside down. And then we just have to remember what our parent function should do. So out to the right one, then left one, and then down 1 instead of up 1. And then out to the right and then 2, and move down 4. Tomorrow, the practice page that I gave you today, you'll be working on. You are welcome to start that now, but you don't have to.